Characteristic impedance of T network at predetermined output voltage. That means designing a T network component for a characteristic impedance with a predetermined output voltage 15% of input voltage like that. In this video, it is clearly explained about ABCD parameter in T network, characteristic impedance, finding T network components for an characteristic with predetermined output voltage and characteristic impedance as load. In the electrical system, maximum power can be delivered to load if load impedance is equal to source impedance. This load impedance is called characteristic impedance. In an electrical two-port network, characteristic impedance is connected to one end and the input impedance of other end should offer same impedance to deliver maximum power to the load. In the electrical system, source impedance depends on parallelly connected generators. Load impedance, parallel feeders should be considered for maximum power transfer from generators along with the generation and the loading capacity. In certain conditions, we have to connect a load, that is characteristic impedance, to a source at lower voltage level. We cannot reduce source voltage because it is offering other system, affecting this other system. So, we can reduce voltage using T network to reduce voltage from source. It will not affect other system and deliver maximum power from source. Two-port network ABCD parameters. In electrical system, V1, I1, V2, I2 are voltage and currents of the system. V1 is in terms of V2, I2, I1 in terms of V2, I2. So V1 is equal to A V2 plus B I2, I1 equal to C V2 plus D I2. That is, if we form in the matrix form, matrix V1 I1 equal to matrix ABCD into V2 I2 matrix. So this matrix is called ABCD matrix. Consider the system which is a T network. That is Z1 is equal to 5 ohms, Z2 is equal to 5 ohms and ZC 3 equal to 20 ohms. The same network can be represented in terms of ABCD matrix. That is, ABCD matrix is 1.25, 11.25, 0.05, 1.25. So V1 I1 is equal to 1.25, 11.25, 0.05, 1.25 matrix into V2 I2. Here, note. No voltage current dependent source in the T network. So matrix A equal to 1.25, 11.25, 0.05, 1.25. V1 is equal to 1.25 V2, 11.25 I2. I1 is equal to 0.05 V2, 1.25 I2. Source is connected to load. Maximum power can be delivered to load if load impedance is equal to the source impedance, that is Z is equal to ZL. This load impedance is called characteristic impedance. Characteristic impedance is connected to one end and the input impedance in the other end. It should offer the same impedance to deliver maximum to the load in two-port network. How to find a characteristic impedance of a T network? Two methods are used. In method 1, characteristic impedance is equal to Z0 is equal to ZSC square root of ZSC into ZTOC. That is the square root of short circuit impedance and into open circuit impedance. Here 5 ohms, 5 ohms and 20 ohms are connected in the T network. So characteristic impedance of this network is equal to square root of 9 into 25, that is equal to 15 ohms. Method 2, Characteristic impedance of network is equal to Z0 is equal to square root of Z1 square in plus 2 into Z1 into Z3. Here Z1 and Z2 are same value. So square root of Z1 square plus 2 into Z1 Z3 is considered here. Square root of here 5 ohms and 5 ohms and 20 ohms are components of the T network. Characteristic impedance is equal to square root of 5 square plus 2 into 5 into 20, that is equal to 15 ohms. Find Z1 Z3 for characteristic impedance is equal to 50 ohms. 15 squared is equal to Z1 squared plus 2 into Z1 into Z3. So Z3 is equal to 15 squared minus Z1 squared whole divided by 2 into Z1. If Z1 is equal to 5 ohms, then Z3 is equal to 200 ohms. If Z1 equal to 10 ohms, then Z3 equal to 6.2 ohms. Like that. T network of characteristic impedance required output terminal voltages. Here see the figure 5 ohms and 20 ohms are connected as a component of T network. ZL is equal to Z0 is equal to 50 ohms. That is load impedance and characteristic impedance. So we see the input impedance of the T network that is equal to 15 ohms. That is, if Z1 equal to Z2 equal to 5 ohms, Z3 equal to 20 ohms, ZL equal to Z0 is equal to 50 ohms are connected. V input equal to 10 volt, then VL, that is output voltage across the ZL equal to 5 volt. That is 15% of VN, V input. If Z1 equal to Z2 equal to 10 ohms, Z3 equal to 6.25 ohms, ZL equal to Z0 is equal to 15 ohms, that is output impedance. Then if we Vn equal to V input equal to 10 volt, then VL equal to 8 volt. That is 80% of 80% of V input. Depends upon the components, the output voltage across the load will vary. Find Z1, Z3 of T network for characteristic impedance equal to ZL equal to Z0 equal to 15 ohms with voltage across ZL, that is characteristic impedance, is equal to 25% of V inputs. That is V input equal to 4 times of V output. Assume voltage across 15 ohms equal to V2 equal to 1 volt. Then current in 50 ohms equal to I2 equal to 1 by 15 equal to 0.06667 ampere. V1 is equal to 4 into 1, that is equal to 4 volt. So V1, V2 and I2 we got it. You see here T network. V1 in this T network ABCD parameters. V1 matrix V1 I1 equal to ABCD matrix into V2 I2. The same can be written like that. ABCD matrix into V2 I2 matrix equal to V1 I1. So ABCD matrix into I, that is 1 0.067 matrix equal to 4 into matrix 1 0.067. Matrix ABCD into matrix of 1 0.067 equal to 4 into matrix 1 0.067. Here Z1 equal to Z2. So A equal to D. Determinant of this ABCD matrix equal to 1. That is A squared minus BC equal to 1. AB matrix ABCA into matrix 1 0.067 equal to, this matrix can be written in equation A plus 0.67B equal to 4. From that, so we find the B. B is equal to 4 minus A whole divided by 0.067. C equal plus 0.067A equal to 0.268. That is C equal to 0.268 minus 0.067 A squared minus BC equal to 1 because determinant of this matrix is equal to 1. By substituting B, C, find A. After that, find B and C. Here in this matrix, after substituting and manipulating, after substituting, we find A equal to 2.125, B equal to 28.125, C equal to 0.125. ABCD matrix equal to 2 matrix of 2.125, 28.125, 0.125, 2.125. That is equal to matrix in terms of components of T network. From this matrix in terms of T network components, we can find Z1, Z2 and Z3. So Z1 equal to 9 ohms, Z2 is equal to 9 ohms, Z3 equal to 8 ohms. In this matrix, ABCD matrix, T network components are Z1 is equal to Z2 is equal to 9 ohms, Z3 is equal to 8 ohms. ZL is equal to, that is characteristic impedance, equal to ZL is equal to Z0 is equal to 15 ohms. With the voltage across, ZL is equal to 25% of V input. That is V input is equal to 4 times of V output. That is equal to 4 into V2. After connecting 15 ohm example, after connecting 15 ohms across output terminals, if V1 is equal to 10 volt, I1 equal to 0.667 ampere, V2 equal to 2.5 volt, I2 equal to 0.1667 ampere. So, Zin equal to, the input impedance equal to 15 ohms for Z0 is equal to 15 ohms. That is output impedance. That is characteristic impedance 15 ohms with V output equal to 25% of V input for Z1 equal to Z2 equal to 9 ohms, Z3 is equal to 8 ohms. It is clearly explained about ABCD parameter in T network, characteristic impedance, finding T network components for and characteristic with predetermined output voltage and characteristic impedance as low. Thank you very much for watching this video. If you need any clarification, you can send mail to us. Our email ID is anbu.electric.y@gmail.com.